Hey everybody, let's jump right in here with Geometry Basics 1. The lesson that we're dealing with here, it's the first lesson out of the book that we are working through, and it's one that you probably did in middle school too. It talks a lot about nets and how they work together to create three-dimensional objects. So basically a net is a two-dimensional drawing that you can fold. It can be folded to make a three-dimensional object. Now, when you are making a net, it should show all of the different surfaces, so all the different faces of the figure in one view. So that means there shouldn't be any hidden faces. Everything should be flattened out to the point where you can see it in a two-dimensional drawing. And what I think the best thing to do in this situation is, I think we need to just draw a few different examples to get an idea of what we're talking about here. And so this top row that we're going to practice first is prisms. Now, a prism is any figure that has two congruent, so that just means equal, the same parallel faces. So basically, for a triangular prism, for instance, you would have a triangle on the left, a triangle on the right, and then sides that wrap around it. So you'd have kind of a 3D example, and then if you flatten it out, that's where your net would come from. So that's what we're going to work through here. We're just going to get some good practice in of what that would look like. So if I move too fast, it's not a big deal because obviously you can just pause the video. So we're going to start with a cube because that's the one that people see all the time. You see dice if you've ever rolled dice. I know I'm not supposed to call them dice. I'm supposed to call them number cubes, but I'm sorry. That's another story. Okay, never mind. So let's say you're looking at a cube, any sort of a cube here. So the way we traditionally would look at a cube in a three-dimensional way would look something like this. You'd have your front face right here. Then if you're looking at it from a three-dimensional aspect, it would be something like that. Then, you've got these lines that are connecting it. Now, what you will also see if you're drawing a three-dimensional object, and for some of you, this might just take practice, but the expectation is on a three-dimensional object, any edge that you can't actually see, just because of your perspective, you should draw using dashed lines. So in this case, that would be here, here, and here. Now that's not perfect, but it'll do for now. That's just fine. Anything even close to that would be a perfectly good cube drawing. So when we get to the net of a cube, this is where things get crazy because I can think of, just based on one of the activities I've seen in the past, one that you'll hopefully do, I have seen 11 different nets of cubes that all produced one. So there's not one correct way to make a cube. I mean, that you could draw the net. Like I said, I've seen 11 different ways that worked. Now, when it comes to a net of a cube, again, there's no one official correct answer. Well, this one will make a cube, but the other one won't. Well, there are a lot of different ways to do it. The most common one that I've seen usually looks kind of like a cross. And I think maybe that's the one that people feel the most comfortable with because you can see, let's say we took this face right here and we called that the bottom. You can visualize the four sides flapping upward, and then you can sort of think of that extra part as a lid. I think maybe that's why this is the most common net of a cube. But again, If you drew something different, that doesn't mean you're wrong. In fact, there's a very good chance that you're right. So I don't want to discourage you if you come up with an idea of something different. The big picture is it's a two-dimensional drawing that you could fold up that would eventually create the three-dimensional object. Now, a rectangular prism, if you're doing it right, you're going to notice a lot of similarities between the rectangular prism and the cube. In fact, technically, a cube is a rectangular prism if we're just being technical about it, because a square is a rectangle. But that's, again, I don't want to get into that right this second. But a rectangular prism is going to have kind of the same idea. The only difference is I'm kind of exaggerating this. I'm making a really, really long front face, but you can kind of see the idea. It's still going to have those hidden edges that we can't really see, that we're just going to make dashed for the sake of this picture, just so the person looking at the picture knows that we know what's going on. There you go. That looks pretty good. And we'll just go with it. Now, your dashes may be in different places depending on your perspective. Maybe you drew a picture with a different perspective, but that's how I'm going to go with it, and we're just going to stick to it. Now, when it comes to the net of a rectangular prism, again, you're going to see some similarities here. You're going to see, in my case, the one that I'm going to choose, and again, there are different choices here. You're going to have a few different things that are going to wrap around. Now, my particular choice here, I'm going to design it a lot like I did with the cube. But my difference here is I'm going to make these 4 faces longer. Because if you really look at that rectangular prism that I drew up there, you're going to find 4 longer sides. Now, the 2 parallel faces on the left and the right, those are still pretty small. So those you can pretty much leave just like we pretty much did on the cube. Now, again, we're not looking for perfection today. This is the first lesson. We haven't even talked about prisms necessarily, so don't feel like they have to be perfect. Okay. Now, in the future, you may end up, we may get into dimensions where you have to label the dimensions. Now, that's just a little extra step. That's nothing that's going to be a big deal here. I think you could do it. For instance, if you see that this is 3 centimeters, then you would want to label on your net, you would want to label that this is 3 centimeters, that sort of thing. Not a big deal. But again, I just want to focus on the basic drawing skills here in this little 15 minutes that we've got together. So let's move on to a triangular prism, which is going to be, I'm going to draw similarly to the rectangular prism, where we're going to have, sort of that longer front face. And then again, it's going to be a triangle on the left and a triangle on the right. Now, in this particular case, you can't actually see that second triangle. It's sort of dashed back here because, you can't really see that. That's not great with the dashes, but you get the idea. So you can see sort of where I'm coming from on the perspective. You can sort of see it's got a front, it's got a back. There's a face on the bottom that you can't really pick up from this 3-dimensional drawing. If I bent the drawing a little bit, if I had tilted that top side a little bit higher, you'd be able to see it. But again, we're just getting basic sketches in. I'm not going to worry too much about it. Now, as a net, what you would find is now, and you're going to laugh when I say this. Well, okay, you might not laugh, but I would say more than half of my students get triangular prisms wrong. And you might be looking at it like, well, why in the world would you get it wrong? You deal with cubes so much that you're used to creating 4 faces that wrap around. 1, 2, 3, 4. 1, 2, 3, 4. And so you get used to it so much that when it comes time to do the triangular prism, you think to yourself that it's going to be 1, 2, 3, 4. It's not. In this case, because it's a triangular prism, it's not going to be 1, 2, 3, 4. It's only going to be 1, 2, 3. And then from there, you're just going to do a triangle on the left, a triangle on the right, and then it pretty much takes care of itself. All right, so let's do a couple more here real quick. And again, if I move too fast, then you can just pause the video. A square pyramid is going to have a square at the bottom, and then instead of having another square at the top, it's all going to come together at one point. I think most people know what a pyramid is. They know history enough to know Egyptian pyramids, all that good stuff. Now, my drawing doesn't look like a square, and I didn't really intend for it to, because the reality is what I really want to demonstrate isn't how it looks from a top-side view. I want to demonstrate how it looks, from a side view, from maybe a three-dimensional view. Now, that's not fantastic. I would have liked those other two lines to be a little bit more separate, but that's okay. And then in this case, I would say we could actually just, if you already drew it, then maybe this won't work for you. But technically speaking, that back edge wouldn't really be visible, so we'll just dash that really quick. Okay, so that's kind of what's going on. Again, not my best work, but just roll with it. From a two-dimensional view, so sort of looking up from the top, that's where you're going to see exactly what's going on. You're going to have a square, and then you're going to have 4 different triangles that all sort of flap up to create that top uppermost point when it's all said and done. Okay, so the net for a pyramid is going to be very different because you're not going to have 2 of the same figure. One on bottom, one on top. It's just going to come together. All right, so now let's get to the can of soup. I like dealing with cylinders because I feel like everybody at some point in their life has had a can of soup. And so if you've had a can of soup, or if I want to make it shorter, it would sort of look like a can of tuna or something like that. The idea is we all have sort of the same experience to where we can look at that and say, oh yeah, that's a cylinder, or oh yeah, that's a can of soup, or whatever. Now, I think what I really like about drawing nets for a cylinder is you can actually visually see what's going on. If you've ever been bored, and if you've ever pulled the label off of a can or anything like that, you can sort of see what's going on here. Essentially, what you've got is a circle on top, a circle on bottom, and then that label, if you were to pull the label off, you're going to notice that the label is actually rectangular. So you don't necessarily recognize it right away, but if you think back to that experience, you realize, oh, I guess that makes sense. You pull off the label and it's just a rectangle. It needs to be a rectangle so that it can wrap all the way around the can, which actually gives you a little hint about what the length of this rectangle is. It has to be long enough to wrap around the top of the can. So whatever the distance around the circle is, that's what the length of the label would be. Okay. All right, now the last thing, I'm going to leave you hanging with this one. I'm going to make the 3D cone. So again, if it's three-dimensional, we can't really see the back there. So we'll just put little dashes there. A lot of people really struggle with the cone, so that's the one that I'm going to leave you with. You can look it up online if you get stumped, or you talk to me another time. But I want to ask you, what would it look like if you had to draw the net of a cone? And that's the one I'm going to leave you with. Have a good one. I'll see you later.